able to analyze the systems you will be building as well as the data you'll be using. Okay. There are two tools we'll look at. We'll look at descriptive statistics and then inferential statistics. All of them are going to help us in our IT activities, especially when we are dealing with real-time system monitoring, and then the most important, the cyber security systems. We need to understand some of these foundations well, so that when we come to predictive models, we can understand them as well as descriptive models. As a result, there are some areas that we will be applying probability and statistics as information technology experts in future. There is a common area which you may come across as you move along in your career called the random number generation, where we use the C++ program to generate some numbers. Now, the theory behind the generation is under probability, which we shall look at very soon. Then there is another concept which you also meet in your IT career called simulations. Sometimes you need to simulate situations in order to see what will happen in future. So some of the models that are used for investments, you will be estimating them using probability when you build such risk models. We call them risk models. You use probability to do that. Then the popular data analysis, which you started from JHS, where you are given some numbers and then you do your frequency table. And then you also do some pictorial representation, that is the histogram, to interpret data. Some also did the bar chart, which also explained data. Others also did the pie chart, which were also demonstrating data. All these graphics are also helping in data analysis, so we can be able to compute certain metrics of data. Now, I want to bring to your attention this afternoon that data is like a material, a cloth. So you have a cloth like this. Normally, when we want our seamstresses and tailors to do a dress for us or to make a dress for us, we give them a cloth or we make them buy a cloth of our choice. So for instance, if you have this cloth as 2 yards, if this is 2 yards like this cloth in this state, it is raw. It is in a raw state because you can't put on the cloth alone as a dress. Okay. There has to be some transformation. This cloth will have to move to another level, whereby probably now your seamstress or your tailor may try to make some dress out of it in a way. Okay. So the moment this cloth changes to become a dress, we say that data here has changed to become information. So data and information in its simplistic definition are not the same. Data are raw facts, information are processed facts. So the reason why we get ourselves busy this semester with probability and statistics is that we want to find every legitimate ways and means to transform data and make it information. That is the bridge we want to bring between these two activities. So the third one, data analysis, we will be computing some metrics like the mean, the median, and the variance of data. And when we start, you really understand the use of probability or statistics. So in that sense, statistics is used when you are doing data analysis. Then there is this popular area also called machine learning, where you are going to train something called classifiers. You may be doing regressions, which I'm not sure you have started. You do it anyway. Now, in all this, you need the basics of probability and statistics. So for this machine learning, you need both. You need both probability and statistics to be able to understand machine learning. Then there's another area called the game development. So game development too, you'll be addressing AI decisions, artificial intelligence decisions in the game development, and all are predictive. So it means anything that is predictive, then probability will have to come in to be able to conceptualize what you are doing in the game development. Okay. Then those in the business world, they do performance benchmarking. And performance benchmarking, you really have to do a lot of runtime analysis. In that case, we use statistics. I know most of these areas, because you have started the program, we don't have too much knowledge about them. That is not my focus. I'm just showing you the areas that probability and statistics can be used when you want to focus on the C++ program, which I'm sure you may be doing now, that you can do C++ in isolation. Some of the C++ processes depends on probability or statistics or both. And so if we have foundation in this course, it will help us to understand or appreciate the C++ program the more. Now, one thing I want you to know, once you're in level 100, I can highlight on it. Your training is in this manner. First of all, we are training you as to how to write algorithms. And I'm sure you've come across this word before. We are training you as to how to write algorithms, step-by-step way of executing a task. So once we teach you how algorithms are written, then we are also teaching you the programming languages to help you to code the algorithms. You code them into soft or programs. At the end of the day, that is what we need from you. In an earlier class, I was explaining your program to them, IT. And I said IT is being formed from two words. The first one is information. The I represents information. And then The T represents technology. Technology, in its simplistic definition, is the application of science to solve problems. Application of science to solve problems. Okay. That is manual stuffs. We need to automate them. That is for technology. What about information? Now, information as it is in its simplistic form, we say information is processed data. Anytime you process data, you have information. Processed data. So if I'm to put the two definitions together, then it means that you'll be involved in processing data in order to apply science to it to solve problems. And that's what I'm just doing here. Anytime I'm developing algorithm for you or writing algorithm for you, the algorithm will have to work on data. I need to squeeze information from data. But then the information, I want it soft. If I want it soft and not manual, it means I need to code the algorithm. How do you code the algorithm? That is why you are being taught the programming languages. You are doing C++. You may do Visual Basics, another one called Visual Basics. As you progress, you may do another one called Advanced Visual Basic.net, which is more advanced than the current one you are doing, all in an attempt to help you to code all algorithms that we develop so you can get your programs or software developed or systems developed. And so if we don't have this foundation of probability and statistics, it becomes very, very difficult to understand how these programming languages work. Now, by simple explanation, we can then turn our attention to the details of probability and statistics. So in a simple language, this is how I have captured the probability and statistics. I'm saying probability is about predicting how. Then we continue. Likely or possibly. Predicting how possibly or likely something is to happen. The thing hasn't happened, it's about to happen. So probability is predicting. So once you are saying predicting, it means that we are going to guess. In probability, you try and do a good guess, and then you have good results. So probability is not about today. It's about tomorrow. It's not about yesterday. It's not about today. It's about tomorrow. So that is probability, predicting how likely something is to happen or something will happen or how likely something will occur or how your guessing can be right about something that is about to occur. Now, what about statistics? It's not the same as probability. Statistics is on a different path. The two of them are not working on the same path. They are working in a local balance, I'll say they are working in separate ways. They are working in separate ways. They are not on the same path. So pictorially, we can say whilst probability is moving in this direction, that is from left to right, statistics is doing the opposite. Statistics is rather moving from right to left. They are entirely different. But as we progress, we'll see whether we should treat them separately or we should, even though they are in different directions, we should treat them together or at the same time. So statistics is when you collect data and then you analyze the data to do what? To try and understand what is happening. It's different from what I read earlier on for probability. Probability is about predicting how likely something can happen. It hasn't happened, it's about to happen. But when you look at statistics, it has already happened. Collecting and analyzing. Collecting what? Data. It has already happened. Collecting and analyzing data to understand what is happening. So it has taken place already. But this time you want to understand what is happening. But the previous one is about to happen. Now, how do we combine the two so we can have a solid foundation? This is how I have captured it. I'm saying probability and statistics are closely related. They are, emphasis, closely related. How are they closely related? I've gone further to say they are like the two sides of the same coin. Adjective, same, not different coins. I'm qualifying the coin with same. They are like the two sides of the same, and I'm excited about this word, same. Two sides of the same coin. Okay, so if this is my coin and then it looks this way, if probability is just on the front view, then means that the other side, which I can't see currently, will be the statistics. So they belong to the same coin, but they are on different directions. But they belong to the same coin, but they are of different directions. And then meaning they are playing different, are not playing the same roles. And how are their roles related? Their roles are related just like the coin relates the front view and then the other side. That is how probability and statistics are closely related. And why do we need these two at the same time? The express example I can give is if you look at yesterday as a day, and then you look at today as a day, and then you look at tomorrow as a day, we can then borrow the word I used here, closely related. So I can say that yesterday is closely related to today. And then today is also closely related to tomorrow. Where is the close relationship? This is what we all know. Yesterday ended at 11:59 p.m. And then today started at 12 a.m. So somebody will say between 11:59 p.m. and then 12 a.m. is just 60 seconds. It's just 60 seconds. Is 60 seconds too much of a time? No. Is 60 seconds too much of a time? No. Therefore, we can say that 11:59 p.m. and 12 a.m. are closely related. Today, again, will end at 11:59 p.m. And then tomorrow will start again at 12 a.m. today. So are they closely related? Yes, because you have 60 seconds between the two. And that is how probability and statistics are closely related. If yesterday and today are forming a coin, yesterday and today cannot be on the same side of a coin. Yesterday will be at the first side of the coin. Today will be at the second side of the coin. Then when you take today and tomorrow, today may be at the first side of the coin. Tomorrow will be at the other side of the coin. Meanwhile, the differences between them is just about 60 seconds, which is not too much of a time. With that understanding, we want to then look at probability and statistics at a very close range with some examples. So a further explanation we can give here is probability helps you, anybody, to make smart guesses about the future based on chances. Probability helps you to make smart guesses about the future based on the chances you have. Let's look at an example in IT. Now, what is the chance that a user, a system user, forgets their password today? What is the chance that a user forgets their password today? If you ask me this question, that what is the chance that a user forgets their password today, I will say it is 50%, like a coin. A coin, when you throw a coin down, either the first side will show or the second side will show. The two sides cannot show at the same time. And so there are some people who forget their password because they have several passwords they use. So sometimes they forget which one they used for a particular access. And so they may forget. There's a possibility that they may forget. So I can guess that some people can forget their password. At the same time, there are others who do not have several passwords. They have only one password that they use for everything. So for such people, if you ask me that what is the chance that a user forgets their password today, I'll still go for the 50%, because sometimes in the course of typing, they may type 0 as O, or their hands may go faster than their mind will think. So they may, in that case, forget about it. In other words, we are saying because of probability, nobody can be perfect. You cannot be 100% on anything. No matter what you do, there will be some chances of errors. And that is how systems also operate. So probability is all about forecasting or predicting for the future. And in that case, the kind of data you generate, we call them the future data, because we don't know, the activity hasn't occurred. The activity must occur before we can generate data. So future data are the kinds of data that we apply the tool of probability to work out an information from them. Then the other side of the coin, statistics. It doesn't make you to carry along this kind of smart guesses based on chances, but rather statistics helps you to understand what happened in the past. It helps you to understand what happened in the past by looking at the data again. Example, in IT, when you are asked how many system users logged into the system this week and how long did they stayed online. This is not difficult. This one, the data will be there. The system will show you the number of users who logged into the system. So probably the system will say 200 users use their login credentials to log into the system. And then after logging in, probably about 150 users were staying online. So that one will also have a record for you. So for this case, the data has been generated already. We call it the past data. Statistics also works best on past data or present data and not future data. So it's like the yesterday, today, tomorrow example I gave. Present data today, past data yesterday can be best analyzed using the tool of statistics. But when it comes to probability, the best data you can use to apply the tool of probability is called the future data. Now, the question is, do we need future data? Do we need present data? Do we need past data? Yes, we need them. The fact that you don't know tomorrow doesn't mean you shouldn't plan for tomorrow. How do you then plan for tomorrow? You plan for tomorrow by using what happened yesterday in addition to what is happening today to plan for tomorrow. So sometimes we need the present data, we need the past data, we need their combination to help us to plan for the future data. Some books call the present and the past data as historical data. So we need historical data to be able to forecast future data. An example, if you have a coin, you know that when you throw the coin in the air, there are two things that will happen. Either the front side where you have the coat of arms will appear, like the way the referee toss it before a football match is started. When they ask the team captains where they prefer, where they like, do you like the front side or you like the other side? Okay. What past data do we have? We know that when you throw a coin, either of this will appear. The two of them cannot appear at the same time, but either the first one will appear or the second one will appear. So that one, we don't have a problem. That is called a past data. And the chances for this are 50-50 or 50% for each. But what we don't know is that when we now increase the coins to 6, let's say instead of 1, we increase the coins to 6. And then you are asking me how many of them will show the front view when they all get to the ground. I cannot say anything because that is not past data. This is future data. It will have to happen before I can count them. And how do I predict? I need to know the past data that a coin can only show one side at the same time. That is how we handle probability and statistics at the same time. We use the past, the present, and the future to summarize data. Now, in IT, one of the things we'll be doing, and I don't know whether you have been oriented on what is demanded of you at the final year. In this school, at the final year, you have to develop a system as your project work. And at the final year, you'll be put in teams of 3 minimum and probably 4 maximum, depending on the number. And you will have to undertake your project work. So the project work you be engaged in at the final year only. You do it at the final year. You start from the first semester and finish with the second semester. There are 3 areas you have to build a system. The first one is either you build a web application to solve a problem, or you build a mobile application to also solve a problem. And then finally, if you can't do any of these, either the web app or the mobile app, then you develop a desktop application, which is localized. So I'm just preparing your mind that you build a system as your project. So either web application, desktop application, and a mobile application. So those of you who are very good in programming, you have to help the others who are having difficulty. But I can assure you by the time you get to the final year, all these things will look very simple for you 3 years from now. Now, these things, why are you? This is the reason why you are in school. In fact, you are doing IT because we want you to build a web app which can help people solve problems, either organizations or individuals, and so on and so forth. Same with mobile app, same with desktop application. Okay. Now, in building these systems, you often use data. You use data to build these systems. Now, where are you getting the data from? You get the data from users of a computing system. You get it from servers. Those of you who understand how servers works, or any other device or devices can give you data to be able to build your system or your software. Okay. Now, before you can use the data, you have to do something to it because data itself by nature are raw facts. On the face value, you can't use it immediately. Data are raw facts. You can't use it immediately. You have to rework. You have to work on it so it becomes information. And then you can use it to summarize what is happening. So the data you get, fortunately, there is information hiding in the data you just need for your work. And until you are able to crack the information, you may not be able to continue with your work. How do you crack information from data to build your system? That is the reason why we are doing probability and statistics. You need probability and then you need statistics to be able to crack data to get information for your model building or your system building. Okay. So all systems that are being used, they are being used based on the theories and principles of probability and statistics. And I want us to look at some examples in information technology and information systems. For instance, when we say you are analyzing a user behavior, how do you do such analysis? When you have built a system, the system is working, but you want to analyze. The users of the system have a certain behavior you want to analyze. How do you do that? You can only use statistics to do that analysis. Now, second concept about security systems. You know that because of the hackers, we always have to make every system that we develop will have to be a robust system because of the hackers. You have to build a robust system. And so how do you ensure that the security systems of your system is top-notch or robust? You need to apply probability to be able to detect any unusual or possible hacking into the system. The security system that is built is based on the theory of probability. And this is another reason why we need to study probability and statistics. Then sometimes when you have too many users on the move, you have network traffic. So with the network traffic, how do you analyze and improve upon the system? You will need statistics to do that, to be able to check various performances at different times. And then the modern way of doing things, looking at how machine learning works. If you want to understand the basics, then this time we need to use both probability and statistics to be able to train all the smart systems we develop in order to make decisions. I don't know whether you've done this course, but there's a course you do called discrete mathematics. I don't know whether you've done it or you do it or you are currently doing it. This will show you the basics of all the smart decisions that a computing systems make. The machine learning, i.e. the machine system, has a machine language where zeros and one are combined effectively to make decisions for the computing system. You know, the computer is not a human being. It uses logic to think. So the concept of logic is used through discrete mathematics to be able to train smart systems to make smart decisions. In a nutshell, we can say, as I've colored in yellow, we can say that probability and statistics will always give us the tools, to do the following. One, to make sense of data or to understand data, to predict useful outcomes for the systems that we build, and then to improve the way technology systems work. This is the reason why we need to have knowledge in probability and statistics, as we started from the other slides. As a result, this is going to be our roadmap for the semester. This is going to be our roadmap for the semester. There are a couple of concepts and theories we want to learn to inform our decision, that we want to really learn and know how data, information, and decisions are interrelated. Data, like I said from the beginning, are raw facts. On the face value, you can't do anything with it. An express example is you have your mobile phone or you have your smartphone. Then you use your subscriber network, whether MTN or Airtel Tigo. Then you bought some bundle or you bundled some data. Let's say you have bundled and then you are paying for this data, so you've bundled it. And then on your smartphone screen, you see a record count that you have 9 gig. You have 9 gig of data. You've seen it with your eye. It is raw. The 9 gig doesn't do anything for you. The only time you understand the 9 gig is when then you start browsing. When you start browsing with the 9 gig, where your internet then opens to any site you want to go, then it means that the data you bought is now changing. Initially, it was raw. They just recorded 9 gig for you, which you understand, but it is raw. It doesn't make any sense until you started browsing, and then the 9 gig packets started working your internet, and then you are able to browse the internet. The moment you start browsing the internet, it means you are at this level. You have now moved from data. Initially, it was data. And then the browsing has sent you to information. So now what is the information? The information is that now you can browse any site. Now you can browse any site. That is what the bundle is doing for you now. The bundle, which used to be data, is now telling you that you have an information. What is the information? Your data has been processed. And so you have information. The information is that you can browse any site. Fine. So if you have information that you can browse any site, you don't stay there. You then need to go a step further. You have to take a decision. And what decision are you taking? The decision is, which site do I want to browse? Which site do I want to browse? So you see where we were coming from. We were coming from buying the bundle becoming data. Then we want to see the data in action. Then the data, we are connected by the system of the subscriber to the internet. So now we can browse the internet, and that ability alone is an information for us that we can browse the internet and we can browse any site we want. But then we can't browse all sites at the same time. So we need to make a decision. And so out of your personal decision, you can pick which site you want to browse. And that is our roadmap. Our roadmap is that, what is data? Data are raw facts. Can we use raw facts to take decisions? No. We can only use raw facts to take decisions after we convert it into information. When we convert raw data into information, do we just stay at the information? No. We need to take a decision as to which information we want to carry across. And so the relationship here is that data are raw facts, information are processed data, or data which has been processed becomes information. Then the last step is information that has also been processed becomes a decision. So before you take the final decision, it means that you have finished processing the information you have. And that is our roadmap for the semester. We'll be dealing with data, we'll try converting them into information, and then we'll also pick our decisions from the information. And some of the metrics that will help us to move from data to decision are the ones I've colored yellow. So we use the tool of central location, the tool of dispersion, the tool of position, the tool of shape on my left-hand side to still crack data and get information out of it. And then we'll continue from now, information to decision. These are the things we are going to use to crack information to decision. One, we'll use probability distributions to get decisions out of information. We'll also use sampling distributions to get decisions out of information. We'll use parametric testings, non-parametric testings, and possibly regression analysis to also get informed decisions from the information we have. And this is a clear roadmap we have. We know where we are starting from, and then we know where we are supposed to end, which we can then relate to our field of information technology. In the process of that, there are two routes or routes that we will use in achieving our roadmap. The first route is that we'll start from a sample. We'll go through the medium of statistics, and then we use the medium of statistics to quantify the sample we have, and then we conclude with the population. Or we will start from population as another route, and then we use the tool of probability to then convert population characteristics into sample characteristics. Let me give you something pictorial for you to appreciate the movement. Now, if I tell you that I have 1 cup of sugar, 1 cup of sugar, like this, and this is the cup, and the sugar is in the cup, plenty like this. Okay. Like we all know, whether white sugar or brown sugar, they are here like this. And then I tell you that now this is your forefinger. Let's say this is your finger. Or let me use another illustration. Let's use your thumb. Your thumb is better. So your thumb may be probably shaped like this. This is your thumb. Okay. Then I tell you that use your thumb, and then just put your thumb in the cup. So you are here. Now you are bringing your thumb. So put your thumb in the cup and press it. Press your thumb. Now, after pressing your thumb in the cup of sugar, when you lifted your thumb, there were some sugar particles like this on the inner part of your thumb. So these were the sugar particles. Now, when I say, okay, these sugar particles on your thumb, can you count them for me? Can you count them for me? This exercise is easy. Yes, you can do it. If you carefully take your time and put them in a tissue, you can count them. That is easy. But when I say the sugar particles in this cup, when I say pour all on a table, like I'm indicating now, and I ask you to count the sugar you are pouring on the table, I'm sure in the first place, you will not even start the exercise, because this is going to be a very difficult work looking at the way the sugar particles look so tiny, you won't even make any attempt to do it. That is how a population is treated. A population is very difficult to count. Very difficult to count. So because we cannot count a population, we always use a sample to talk about a population. We always use a sample to talk about a population. So this same sugar that is on your thumb that you pressed on the surface of the sugar, probably when I say count, you counted about 100 pieces. Now these 100 pieces, if I say the next level, try and taste these 100 and give me your verdict. And then you tasted this 100 pieces of sugar or particles of sugar. And then your taste bud is saying the sugar is sweet. Immediately, your mind will tell you that the whole sugar in the cup will taste the same way you tasted it from your thumb. That is how sample works out to population. That the characteristics of the sample is assumed that you have the same characteristics in the population. It is natural. So nobody will say, okay, probably it is the surface that is looking sweet. Let's try and go to the bottom of the cup to see whether the particles in the bottom of the cup are also sweet. Your mind will not go there. All that your mind will tell you is that once the you took, that the whole thing in the time we use samples to talk about population. And the only way you can use samples to talk about population is when you are using statistics. You use statistics, apply it on samples, and then you generalize it to population. So that is the first route. Now, the second route is this other example, that when you now have the whole population, which is the cup, is it possible to take a sample from the population? Yes. If you don't want to deal with the whole sample, we just put our thumb in it and then we get a sample. In other words, anytime you are looking for a sample, just go to the population. You get the sample. So the ways that you can always have sample from population, it means you need to move through the route of probability. Probability brings you from population to sample. And then statistics also takes you from sample to population. In that sense, we now want to put everything together now and then tie the knots finally. So the roadmap said that we are moving from data to information, and then out of the information, we are able to pick our decision. And then the express IT examples I can give you are as follows. 1, what are raw facts in IT? What are data in IT? I'm saying in IT, anytime you have raw logs, anytime you have sensor outputs, if you don't understand raw logs, if you don't understand sensor outputs, as for this one, you will understand. Anytime you have user clicks, anytime you have network packets, anytime you have database entries, all these qualifies to become data in IT, or they are raw facts. What do you do with raw facts? Raw facts, you can't do anything with them until you squeeze information from them. And those of you who are already in IT, you know how web server logs show request timestamps every time. You also know how IP addresses work, and you also know how response codes are recorded. All these are examples of raw facts. We need to process them. If you get a raw fact and you don't process them, you won't have any information. So from these raw facts, how do we then get information? And this is the example I have given again, that in IT, after collecting all these raw logs or data, you need a system to clean and process it. Once you clean the data and you process the data, it will produce information. So you move from data to information. And some of the information is what we have been using in our various homes. Example, intrusion detection alerts. So when you have some alerts, it means something has happened. Some data has been processed by a system. And so something has been tampered with. And then something will have to check it up at the end of the day. So data always will produce information. If your phone you use every day, you refuse to key in the correct password, your phone will not respond. In fact, those of you who use iPhone or iPhones, you see that sometimes if you forget your password and then you wrongly type it 3 times, the system will disable and then punish you by not allowing you access for some time. It will just get locked up. Why? Because intrusion detection has been activated. Your password is supposed to be data for the system. And so because you didn't put in the correct data, the system is not going to give you access into it. And in discrete maths, they will show you or they will teach you or you'll be taught how some of these intrusion detection alerts can be seen when the machine detects that there is no configuration between what you have inputted and the information that is coming out. So that is moving from data to information. What about moving from information to decision? Okay, so these are some of the decisions that can arise from the information we get. Remember, the systems I'm saying you are going to build, the systems are going to make decisions logically, with the aid of data and information. So we can separate them. And some of the decisions are you will see a system optimization decision from the kind of system you are using. If there is a security threat detection tool, decision will be made whether to block you. It's like an ATM. You go to ATM and then let's say your password is 1234 You know it is 1, 2, 3, 4, but you don't know the order. So you went in and then you keyed in 2, 1, 3, 4. And then there was a first threat. So you were warned that wrong password. And then you go again. And then you type 3, 4, 2, 1. Then the system detects that the second data tool that has come, it means you don't have information about that account number. So immediately detection is made by the system. So for the system to protect itself, immediately your card will have to be captured because you are a threat to the system. You are not conforming to the configuration. And that is a decision. That is the decision the ATM machine will have to take because it has processed all the information you are keying and has realized that you are not the owner of the account number because you are keying in wrong account numbers. Again, there are other decisions that are made when user behavior are being analyzed. And then in cloud computing, you have capacity planning in cloud systems. All these IT systems are based on what our roadmap is telling us. We start from data, we move to information, and then we end with a decision. So like the ATM machine, it is demanding a data from you, which is your password. You key in the right password, information is activated. The system makes a decision, you are the right owner. The system gives you access to withdraw your money and go. You key in wrong password, data, information goes that you are not the right owner. You are given to be sure. After validation, you key in another wrong number, a decision will have to be taken. It means you are not the right owner of the account. Decision. Very interesting IT systems that helps our robust security in good systems that are already running. And so all these things are able to happen because of the foundations of probability and statistics. And like I said, this is the roadmap. Statistics, probability in IT are going to move us either from left to right or from right to left. When it is the movement is from left to right, it means we use the bridge of statistics to operate. When the movement is from right to left, it means we use the tool of probability to work. And why do we need all this? Because all our systems we design will be based on decisions. We are going to allow the computing system to decide the action to take. And once decisions will be taken, it means information must be present. Once information is present, it means some data was keyed in somewhere. That is why it has been processed and then information has been gotten and then a decision is coming out from the information. This is the sort of thing that will really engage us for the whole of the semester. So in summary, this is where I want to conclude for today. Today is introductory. I'm just introducing the course today, and then God willing, next week we can properly take off. So in conclusion, we say that probability and statistics is a two-way bridge. It's a two-way bridge, and I've drawn the bridge for you already. The bridge was our road map, and this is the bridge. Let me tidy it again. Probability and statistics helps us to do two things. Number one, first bridge, we climb. Sample will climb through the bridge of statistics to get to population. And then population will also climb through the bridge of probability to get to sample. And the thing is like a cyclical behavior. You move from one point to the other, you turn around and then come back, and then it becomes cyclical, continuous. You keep moving, you keep moving, you keep moving. If you forget about this example, just look at today and tomorrow, how they move into each other. Today and tomorrow, they always move into each other. Today was yesterday, and then today will be tomorrow's yesterday, and then it keeps going like that. But in concluding with IT concepts, which I don't want to go too much because you haven't done a lot of IT stuff, I just want to end somewhere here for you to appreciate what we will do. Now, we say statistics helps us to understand IT systems in a practical way. So every data point in IT, every data point in IT must be analyzed. So all the log files in the computing system, all the user sessions that we open, all the network traffic, they must be analyzed, because if we don't analyze them, how would we know the number of people? Sometimes doesn't it amaze you the way the log files shows you a lot of data that has come into a system? Okay. Now, when the log files become too many, it doesn't make sense. So the only way we can make sense out of it is to, first of all, summarize it and then analyze them. How do you say a system is good? You can only summarize and analyze the system, and then the results you get will tell you that the system is good. And statistics will always come in to help us. Let me write the key word we learned today. Statistics will always help you to understand what is happening, understand what is happening. That is one side of the coin. And then probability will always help you to predict, or another common word which you cannot forget, guess. It will always help you to guess what is about to happen. It means that it hasn't taken place. What is about to happen. These are two different things. And then we need these two to be bridged. when we have understanding of what is happening, and we can also predict what is about to happen, then I think it makes all of us very safe. And so we can safeguard our system and so on and so forth. So I'm sure if you are the technical head for MTN mobile money section, you will not be sleeping, because your probability and statistics should be working together every time. You have to be one step ahead of the scammers, because they are devising new ways to redeem all these IT stuff, log files, user sessions, network traffic. You have to outsmart them by making your system robust. So, in conclusion, if you don't know, if you don't understand what the scammers are doing, if you don't understand what the scammers are doing, how do you then predict what they are about to do? So that is where your expertise comes in. First of all, you need to understand how the scammers are able to crack the system, and then predict what they want to do next, so you can always go a step ahead of them. So on that note, we can say that the link between statistics and probability forms the foundation of data-driven decision making in IT. I repeat, from what we have learned today, we can say the link between statistics and probability, which I just did it. We move this way, sample to population, and then we moved again from population to sample. And then we learned that in the movement, when you are moving from one side to the other, this side you use statistics to do the movement. And then when you come here, you use probability to do the movement. So the link between, so watch it, the link between probability and statistics forms the foundation of data-driven decision making in IT. In other words, before the decision systems can work well, data must be processed into information, and then information must be processed into decision. And I wish in your own spare time you can read about data-driven decisions in IT, or data-driven decision making in IT. And some of the areas you can look at are, you can read more on network management. If you haven't gotten there, don't worry. I think it's level 200. But I wish you could read about it before you get there. You also have to read about system reliability, and then artificial intelligence. Even though you have heard about artificial intelligence, I want you to increase your knowledge there a bit. And then the very important one to cyber security. In this time, you need more knowledge about cyber security, so that when we have data from cyber crimes, we can be able to deduce information, and then we will enhance our systems to put up a robust decision that can destroy the works of the scammers. So this is my last statement for today. We are ending at slide 15. Hopefully next week by this time we'll continue from this side of the slides. But before I end, the floor is open for questions. If you have any question on what we have done today, please, you can raise your hand up and then I can respond to your question. Any questions so far from what we have done today? Probability and statistics introduction. Any question from any students? And those of you who are using the names Zoom user, because of attendance, I want you to change it to your names so that it will be recorded as well. You can change it to your names. Very important. If you don't know how to do it, let somebody help you do that for the records. So any question? I saw a hand up. I was about to attend to you, but I think you've gone off again. Any question for today? All right, so once no hand is coming up, we can end the class today. And hopefully, God willing, yes, Solomon, unmute yourself and ask your question.
Sir, please forgive me. Good evening, and thank you for your time. My network was not stable, so
No problem.
it seems I heard you giving assignment. Please, if you can repeat it.
Oh, okay. It's not an assignment. It's a suggestion I was giving that I know you are all busy. You are only able to make it to school during the weekends. The weekdays, I know majority of you are working, but I'm saying that because you are doing IT and that is what you have chosen to do, there are some basics that I want you to read so that you understand what we are doing. And I was saying that if you have time, read on foundation of data-driven decision making in IT. Or you can look for areas such as network management in IT, system reliability in IT, artificial intelligence, and then cyber security, because you need to have knowledge in these areas in order to appreciate the course. So it was a recommendation I was making. It wasn't an assignment necessarily. It is just a recommendation to enhance your knowledge in what we are doing. Any other question? All right, so I'm sure you started lectures from the morning, 7 a.m., and most of you are tired now. Let me not stretch you any further. And you have done very well and keep doing that every weekend. On that note, I want to thank you for your participation today, and I wish you all the best this week. Have a good week. Till we meet next week. The class is ended for today.